NASA has just revealed one of the most intriguing discoveries ever made on Mars. A rock sample collected by the Perseverance rover is showing signs that could rewrite what we know about the planet's past. Somewhere inside Jezero Crater, Perseverance drilled into a piece of ancient stone. What it found inside wasn't just dust and rock. It was a chemical fingerprint that has scientists around the world paying very close attention. So what exactly is hidden in this rock? Why is NASA calling it one of the most significant moments of the mission? And what does this mean for our future exploration of the Red Planet? Let's dive in and follow this discovery step by step. Hello and welcome. I'm Orion, coming to you from Infinite Universe NTH. To understand why this discovery is so important, we need to take a step back. Our search for life on Mars didn't start yesterday. In 1976, NASA's Viking landers carried out the first experiments to look for life on the Martian surface. The results were mysterious, hinting at possible biological activity, but never giving a clear answer. For decades, the question remained, was Mars ever alive? Then came a new wave of explorers. Spirit and Opportunity rovers roamed the planet for years, finding evidence that liquid water once carved valleys and soaked the soil. In 2012, Curiosity drilled into ancient rocks and discovered that Mars had the right chemistry to support life, but still no direct signs that life had been there. Perseverance was built to go further. It landed in Jezero Crater in 2021, a place that was once an ancient lake fed by a winding river delta. If life ever took hold on Mars, Jezero would have been one of the best places for it to exist. Armed with cameras, spectrometers, and a drill capable of collecting perfect cores of Martian rock, Perseverance began its mission: search for signs of ancient life and gather samples that one day will be brought back to Earth. In July 2024, Perseverance reached a site deep inside the Bright Angel Formation, a region that scientists had been eager to explore ever since the rover first landed. Here, in a layer of ancient mudstone, sat an outcrop nicknamed Cheyava Falls. From orbit, this feature stood out, hinting at a history shaped by water. On the ground, Perseverance confirmed it was a prime candidate for coring. On Sol 1236 of the mission, the rover extended its robotic arm, positioned the drill carefully against the rock surface, and bored a perfect cylindrical core, a window into billions of years of Martian history. A titanium tube sealed the sample, preserving it for the journey back to Earth one day. As the data began streaming back, the first images revealed the fresh drill hole and the newly collected core, a reddish-brown cylinder just a little thicker than a pencil, packed with fine-grained Martian sediment. The team in Mission Control watched closely, knowing they had just captured a piece of rock that had been undisturbed since a time when Mars was far wetter than today. But it wasn't just another successful sample. As Perseverance ran its onboard instruments on the core, subtle signals began to emerge. Patterns in the chemistry that hinted this rock had a more complex story to tell. Scientists quickly flagged it for further study, giving it the name Sapphire Canyon. For researchers who had spent decades searching for clues to Mars's past, this moment was thrilling. Each line of data suggested that the story written inside this rock might be unlike any they had seen before. What exactly was locked inside Sapphire Canyon? Why did its chemistry stand out from dozens of other cores collected by Perseverance? The answers would take weeks of careful analysis, but what they revealed would soon capture the attention of the entire world. When the science team began analyzing Sapphire Canyon in detail, they quickly realized this was no ordinary core. The rock's fine-grained mudstone suggested it had been deposited roughly 3.8 to 3.5 billion years ago, when Jezero Crater still held a lake. But the chemistry revealed an even more complex story. Perseverance's instruments detected reaction fronts, narrow zones where the rock's chemistry had changed, evidence that water had moved through the stone long after the lake had dried up. This meant that Mars wasn't just wet once. It stayed active for far longer than scientists once believed. Even more intriguing were the minerals hiding in those altered zones. The rover identified vivianite, a blue-green iron phosphate that only forms in wet, oxygen-poor conditions, and greigite, an iron sulfide that, on Earth, is often associated with microbial activity. Finding both together in the same sample was rare and exciting. Then came the most headline-grabbing result. Perseverance's Sherlock spectrometer detected organic carbon, the building blocks of life. These molecules can be made by purely chemical processes, but finding them inside a rock that had been chemically altered by water raised new questions. Put all of this together, and Sapphire Canyon became one of the most promising samples ever collected on Mars. It contained evidence of long-lasting water, chemical energy sources, and organic molecules, three of the key ingredients needed for life. On Earth, this combination is found in places like river deltas, marsh sediments, and lake bottoms, where microbial life thrives. NASA's Dr. Amy Williams described the finding as one of the most compelling collections of potential biosignatures ever identified by Perseverance. The team was careful to stress that this is not proof of life, not yet. But it is exactly the kind of sample they had hoped to collect when the mission was first conceived. For that reason, Sapphire Canyon has been placed at the very top of NASA's Mars Sample Return Priority List. If all goes well, this core could be back on Earth by the early 2030s, ready to be sliced open, examined under the most powerful microscopes ever built, and maybe finally answer the question we've been asking for half a century. Sapphire Canyon is now more than just a Martian rock. It has become the centerpiece of one of the most ambitious science missions ever attempted, Mars Sample Return. Over the next several years, NASA and the European Space Agency will work together to launch a series of spacecraft to Jezero Crater. Their goal is bold: collect the sealed cores Perseverance has stored, place them aboard a small rocket, the first ever launched from another planet, and send them into orbit, where another spacecraft will capture them for the journey home. If the timeline holds, these samples could land on Earth in the early 2030s. For the first time, scientists will hold pieces of Mars in their hands, material untouched for billions of years. They will use the most advanced microscopes and spectrometers ever built to search for tiny patterns in the carbon molecules, isotopic fingerprints that could reveal biological processes and textures that only living things could have created. And then, the world will get an answer to a question that has driven decades of exploration. Did life ever exist on Mars? Imagine that moment. If the answer is yes, it means life is not unique to Earth, that the universe may be teeming with worlds where life could arise. And if the answer is no, that result is just as profound, telling us that life might be far rarer and more precious than we ever imagined. Either way, this discovery will reshape how we see our place in the cosmos. For now, Perseverance continues its lonely trek across Jezero Crater, drilling, caching and preparing for the day these samples begin their journey home. Each core is a time capsule, a message from a world that may once have been alive, and that message is still waiting to be read. Thank you for joining me on this journey. I'm Orion, and this is Infinite Universe NTH. If you enjoyed this deep dive into Mars's latest discovery, consider subscribing, because when these samples finally make it back to Earth, we'll be right here to witness history together.